Today we're going to talk about how to use parallel lines in geometry. So the way that you recognize something's parallel is you draw a little line here and a little line here, and that means that these two lines are parallel. If you remember from past lessons, parallel means that these two lines will never cross. They're always just going to stay parallel to each other, like train tracks. Okay, like two lanes of a highway. They're never going to cross. They're always just going to stay parallel to each other. This line right here that's cutting across them is the transversal. And the transversal helps us to know things about the angles of these different parts. So for instance, let's say we have this blue angle here and this orange angle here. We know that this orange part plus this blue part over here is going to equal 180 degrees, because whenever you have a straight line like this one right here and you make two angles that fill in all the available space, so like you have the orange angle here and the blue angle here, we know that whenever they're right next to each other, they're always going to be supplementary. Supplementary means that these two angles are always going to add up to 180. So that's the first thing that you should know about parallel lines. What happens though, however, if we're talking about this angle right here and this angle right here? Well, if you remember, the orange angle up here, it's on the top side and it's on the right side over here. This one over here is also on the top. It's on the top side and it's on the right side. So they are corresponding. Corresponding just means that they're in the same place on both lines. For instance, this line right here would also correspond to this line right here, because they're both on the left side of the transversal, and they're on the bottom. They're both on the bottom on the left side of the transversal, so they're corresponding. And corresponding angles are always equal. They always equal each other. So like for instance, if this one was, let's say, 150, this blue one right here would also be 150. And the other thing to remember is that vertical angles are congruent. So this one and this one are also congruent, because vertical angles are congruent. Vertical. Because they're on opposite sides of the if you're on the opposite side of two intersecting lines, here's one intersecting line right here, and here's the other intersecting line right here. If you're on opposite sides, then they are equal. So this one equals this one, and this one equals this one, in the same way that this one right here would equal this one right here, and this angle right here would equal this angle right here. And so you can see there are lots and lots of relationships when you have two parallel lines. There's lots of things that you can figure out about them. For instance, the other thing you need to know is that the alternate interior angle, alternate means opposite. So both of these are on the inside of the parallel lines and they're on opposite sides. Those are called alternate, meaning that they're on opposite sides of the transversal. Alternate, and they're both on the interior, they're on the inside. So the alternate interior angles, those ones are also equal. And in the same way, the alternate exterior, so here's one on the outside of the parallel lines and here's one on the opposite side of the parallel lines. The alternate exterior, alternate exterior are also equal. So there are so many relationships when parallel lines are happening, and then you have to be able to know all of them, or at least some of them, so that you can work with and be able to solve parallel line problems. For instance, let's look at our first parallel lines algebra problem. Let's say that you know this angle right here is 2x. Let's say that you know this angle right here is 3x plus 5. Now, if you look at these angles right here, they're both on the right side of the transversal and they're both on the top. They're both on the top of the parallel line and they're both on the right side of the transversal. So we know that they're corresponding, so we know that they're going to be equal. So we know that the 2x is going to equal the 3x plus 5. And if we subtract 3x to get the x's all on one side, we know that 2 minus 3 is negative x, or negative 1x, equals 5. And if we divide both sides by -1, divide both sides by -1, x is going to equal 5 divided by -1, which equals -5. And so we know that in this case, x equals -5. Let's try another one. Let's say we know that this one and this one, let's say we know that this one is 3x plus 2. And we know that this one right here is 5x minus 7. 3x plus 2, 5x minus 7. These things are on the opposite sides of the exterior. So if they're on opposite sides of the exterior, they're alternate interior angles. And if alternate exterior angles. We know that alternate exterior angles are equal. So we would go 3x plus 2 equals 5x minus 7, and we would solve it. Let's do minus 2 to get rid of the 2 on that side. So we're going to have 3x is going to equal, these ones cancel out, it's going to equal 5x minus 9. And let's subtract 5x from both sides, minus 5x from both sides. 3 minus 5 is -2x is going to equal -9. And I'm going to rewrite it up here. -2x equals -9. And we're going to divide both sides by -2. And so x is going to equal, a negative divided by a negative is a positive. It's going to equal 9/2. And that is going to be your answer for that problem, 9/2. And so you can see you have relationships between these different parts of the parallel lines. And that is how you solve those kinds of problems.